This is going to be a short video, I promise, on the difference between heat and temperature. So I need to start off with definitions, or descriptions, I guess. Heat is energy. Temperature is some kind of a rating, okay? I'm not sure if I'm doing this exactly how I want. If it goes well, then I'll keep it. Otherwise, I'll reshoot this video, but let's continue. Let's say you've got a few particles, and this one's going really fast, and this one's going slower, and this one's kind of going in betweenish, maybe fast. These guys all have kinetic energy, okay? So if we took these numbers, you know, this guy's kinetic energy, this guy's kinetic energy, this guy's kinetic energy, X, Y, and Z, if we added all three of those up, we would have the sum of the kinetic energy, and that is the heat present in this sample. So heat is a measure of energy. Okay. Now temperature. Let's say we've got a few particles again here. This one's going fast. This one's going slower. This one's kind of going whatever. And what we do here is we take these three different speeds, or these three different energies. We've got our X, our Y, and our Z. And we're going to take these and we're going to average them. So it's going to be X plus Y plus Z divided by 3. So that's going to be our temperature. So heat measures energy, the total energy, the sum of the energy. And temperature is a rating of the average of all of the particles in that sample. So that's the difference. So if you heat up a substance, its energy will go up and its temperature will go up. I think that's actually worth writing down. I'm going to write that down and I'll be right back. Okay, so we use the letter Q for heat. So if you heat something, its heat goes up and its temperature goes up. That makes common sense. But what if we cut something in half? So cut in half. So if we cut something in half, its temperature might not change, and its amount of heat, since it's less now, we take the other half away, its heat went down. So the heat went down and the temperature stayed the same. So I don't know if this is the best place to do this, but there's something called an intrinsic property, and there's something called an extrinsic. And intrinsic properties, those are properties where like the amount of the substance doesn't matter. So, or a better sciencey word, the mass of the substance doesn't matter. And an extrinsic property, the amount of substance that you have does matter. So between these two, which one says to you intrinsic and extrinsic? Maybe a good time to pause the video for a second and take some guesses. So an intrinsic property, one where the mass doesn't matter, that is going to be the temperature. Okay? And an extrinsic property, where the mass does matter, that's going to be the heat. Okay? A way to spell this out, think about this. Think about out in the ocean, you got this giant iceberg, and then you've got a little stick person here holding a match. Let me put a little red dot on that. There, a little person holding a match. So what have we got going on here? We've got this giant hunk of ice, and you know that it's got a low temperature, and we've got this little tiny match. We know that it's got a high temperature, but this giant chunk of ice has a whole lot more heat energy than this tiny little match does. So this one, Q, is really high, and this one, the Q, is really low. So that's just an example of intrinsic versus extrinsic. Alright, so I'm under 5 minutes. I told you it would be a short video. See ya.